class. In this session we are going to continue the topic kinematics. It's question number 17 from the same exercise, and the question says a particle travels in a straight line, passes a fixed point O with a velocity of 1/2 meters per second. So you have the value of velocity, it's 1/2 meter per second, or you can say that it's 3 divided by 2 meters per second. Alright, it moves in such a manner that t seconds after passing O, its acceleration A is given by, so you have the expression for acceleration, it's p plus qt, where p and q are constants. Given that its velocity is, now the data we have, its velocity is 3/1/2, or you can say that 7 divided by 2 meters per second, when the value of time is 2, and that it comes instantaneously to rest, and after that the velocity is 0 when t is equals to 3. So I can say that velocity equals to 0 at t equals to 3. Calculate the value of p and q, and after that it says find the distance traveled by the particle between t equals to 1 and t equals to 2. So firstly we need the expression for velocity, and we have the expression for acceleration, A equals to p plus qt. Alright, in order to obtain the expression for velocity we need to integrate on both sides. Alright, so when you integrate the acceleration you will get velocity is equals to integral of p, it will be pt plus q, integral of t, it's t square divided by 2, and the constant c we need to introduce here. Now firstly we need to find out the value of c, and for value of c you have the condition that when the velocity is 3/2, alright, the value of time is 0. So you got your value of c, and it is equals to 3 divided by 2. Now the expression for velocity we have, it's p plus q t square upon 2 plus 3/2. Alright, so we have used the first condition. For next one, we know that when velocity is 7/2, so the value of time is 2. So now we need to apply the same condition in this equation. So you need to give it a try first. What you need to do, first you need to place the value of velocity 7/2, time value is 2. You will get an equation in terms of p and q, and for next equation when velocity is 0 the value of time is 3. So you have two conditions, you need to place the conditions in this equation and you will end up with two equations. So give it a try. You have a time of 3 minutes to find out these two equations. So start. Alright, so for the first condition, at t equals to 2 velocity is 7/2. So I am going to place the values here. Velocity is 7/2. t, the value of time, it's 2 plus q t square, it will be 4 divided by 2 plus 3 divided by 2. So you will get 2p plus 2q plus 3 divided by 2 equals to 7 divided by 2. We can take LCM on the right side, so it will be 4p plus 4q plus 3 divided by 2 equals to 7 divided by 2. If you simplify, 2 and 2 cancel, so the leftover part 3, when you shift on the left side, 7 minus 3, it's 4 equals to 4p plus 4q. You can divide the whole equation by 4, so you will get 1 equals to p plus q. That is your first equation. For the next equation we are going to use when velocity is 0, so the value of time is 3, and we need to place the values in the equation. So it will be 0 is equals to t is 3, so it's 3p plus t square, so it's 3 square is 9q divided by 2 plus 3 divided by 2. Taking LCM here, it's 2, so that will be 6p plus 9q plus 3 equals to 0, and it's 6p plus 9q plus 3 equals to 0 and 2 shifts on the left side. You can take common 3 here, so it's 2p plus 3q plus 1 equals to 0, and the equation we get is 2p plus 3q equals to -1. That is my second equation. Alright, now I need to solve them simultaneously. So I will multiply my equation 1 by 2. So it will be 2 equals to 2p plus 2q, and I will write the equation here, 2p plus 2q equals to 2. Alright, we can simplify it, but before that we need to change the sign. So it's minus minus minus. 2p and minus 2p cancels. So 3 minus 2q, it's q, and minus 1 minus 2, it's minus 3. If we got the value of q, it's minus 3. Once you got the value of q, I can place the value of q in this equation. So it says 1 equals to p plus q, p is minus 3. So you got the value of p, it is equals to 4. Alright, so now you have the value of p and q. The equation of acceleration will become now a is equals to p is what? P is 4. So it's p minus q is minus 3 minus 3t. So that is your acceleration. Alright, you need to find out the distance between 1 and 2. Alright, so firstly, when you integrate it for the first time, you got the value of velocity, and the expression for velocity we have find out, it's this one, right? It's pt, this one, plus qt square divided by 2 plus 3 divided by 2. Alright, that is your velocity expression. Now you need to integrate it again for the displacement expression. So when you integrate it, it will be pt square divided by 2 plus q upon 2 present. T square integral is t cube upon 3 plus 3 upon 2t, and we need to introduce the constant, that is d, because c is already being used. Alright, now when p is 0, so displacement is 0 as well, and we can get the value of d equals to 0. So the value for displacement is, in fact, there is no need to find out the value of d. And why is it so? Because in this question, when you need to find out the value of displacement, you have the range that is from 1 to 2. Yes, from 1 to 2 you have the range here. So I'm going to apply the limits from 1 to 2. Alright, secondly, I need to place the value of p and q here, which we had find out. So value of p, it's 4, and value of q, it's minus 3. Alright, so now it is displacement is equals to 2t square minus 3 and 3 cancel, so that will be d cube over 2 plus 3 over 2 t, and the limits we have it from 1 and 2. Alright, so give it a try first. You have a time of 2 minutes to simplify the expression and find out the value of distance. So start. Alright, so when you place the upper limit, upper is 2, so it will be 2 square, it's 4 minus 2 cube 8 upon 2, it's 4 plus 2 and 2 cancel, so it's 3. So that is my upper limit, minus. For lower limit, it's 2 minus 1 upon 2 plus 3 upon 2. Alright, we can simplify. 2 4s are 8, 8 minus 4, 4 plus 3, it's 7. So 7 minus, inside the bracket you can solve. So first we need to take LCM here. So that will be 4 minus 1 plus 3. 4 minus 1, it's 2, 2 plus 3, it's 5. So 5 upon 2 and 7 minus, taking LCM, it will be 14 minus 5. And there is one mistake, that this is not 5. 4 minus 1, 3 plus 3, 6. So it will be 4 minus 1, 3, 3 plus 3, 6 divided by 2. Alright? So when you simplify, you will get 7 minus 3, which is equals to 4, and that is your final answer. Alright, so I hope that all of you have a clear idea how we solve this question. At first, the concept of simultaneous equation we have applied, and then the similar concept of integration to find out the value of displacement. Moving on to the next one. It's question number 19. At first, we need to read the question carefully. A particle moving in a straight line passes a fixed point O on the line with velocity 30 meters per second. So you have the velocity 30 meters per second, and it says moving in a straight line passes a fixed point. So when t is 0, velocity is 30. The acceleration is given by a is equals to 13 minus 60. Calculate for the first part the velocity of the particle 3 seconds after passing O. Now, you have the expression for acceleration, right? When you integrate, you will get the velocity, but also a constant c. And for c, you have the condition when t equals to 0, velocity is 30. So we have attempted several questions with the same concept. You have a time of 2.5 minutes. So give it a try and then I'll explain. So start. Alright. So firstly, it's a acceleration equals to 13 minus 60. Alright. So the integral, it will be velocity is equals to 13t minus 60 square divided by 2 plus c. So you can say that velocity equals to 13t minus 3t square plus c. Alright. To find out the value of c, we have the condition that when t equals to 0, velocity is 30. So it's 30 equals to, it will be 0, and the value of c we can get easily, that c is equals to 30. Alright. So the final expression for velocity we have, its velocity equals to 13t minus 3t squared plus 30. Alright, I hope that all of you are getting the same expression for velocity. And it says the velocity of the particle 3 seconds, so that means the value of time is 3, so it will be velocity equals to 13. The value of time is 3 minus 3, the velocity value of time is 3 square plus 30. So 13 3s are 39 minus 3 square, 9 3s are 27 plus 30. So 30 minus 27, it's positive 3, and 39 plus 3, it's 42 meters per second. That is your first part answer. Alright, for the next one, part B. The time taken, the time is unknown now, to reach the maximum distance from O in the direction of initial motion. So you need to find out the value of time and the time it reached for the maximum distance from the origin. So how you are going to find this one? Firstly, I need to find out the expression for distance, and we have the velocity expression, that is 13t minus 3t square plus 30. We need to integrate the function to find out distance. So that will be 13t square upon 2 minus 3t cube upon 3 plus 30t, and then the constant d. At t equals to 0, displacement equals to 0. So with these two parameters, you know that t equals to 0. Alright, so the final expression for distance we have, it's 13 over 2 t square minus t cube plus 30t. Alright, now the important phrase in this part is maximum distance. With the concept of stationary points in differentiation, we know that for maximum distance we need to find out the stationary points, that means ds over dt equals to 0. So you need to derivate your expression and equate it to 0 to find out the value of t. So when you are going to start differentiation, ds over dt, it will be 13t, the power 2 and this 2 will be cancelled, minus 3 t square plus 30, and ds upon dt equals to 0. So you have an equation minus 3t square plus 13t plus 30. We can solve the equation by using the middle term. So firstly I need to arrange the signs here. So it's 3t square minus 13t minus 30. Alright, the middle term. What we need 90. Alright, and 90 is 15 times 4. So it will be 3t square minus 18t plus 5t minus 30 equals to 0. You can take common here and it's 3t. Inside the bracket it's t minus 6 plus 5 and t minus 6. Alright, equals to 0. So you have 3t plus 5 equals to 0, and you have t minus 6 equals to 0. So you got two values of time, it's minus 5 over 3, and you got t equals to 6. So we need to ignore the negative value because time can never be a negative quantity. Now we need to find out the distance at time equals to 6. So we have the expression for distance is 13 over 2 t square minus t cube plus 30t, and the value of t we have it 6. Now we need to simplify. So it's 13 divided by 2, 6 square is 36 minus 216 plus 180. Alright, now it will be 36 into 13 divided by 2, it's 234 minus 216 plus 180, it's minus 36. So 234 minus 36 leads to 198. So we have the maximum distance, it's 198 meters, and the time value when it is maximum. Alright, so if you read the question again, in the second part it talks about the time, that is 6 seconds, and in the C part it talks about the maximum distance. So the maximum distance we have it's 198 and the time is 6 seconds. Alright, so that is the complete of your question, completion of the question, and you need to write down the solution in your copy. And for this complete part you have a time of 4 minutes. So start. Alright, so moving towards the next question, that will be the last question of this session and this exercise as well. And the question we have attempted so far, that is basically the exam style questions. The question says a particle moves in a straight line from a point O in the line so that t seconds after leaving O its velocity is given by, the expression for velocity we have it's 3 e to the power 0.4 t plus 2. Calculate the initial acceleration. Now the word initial says that the value of time is 0 here. The initial acceleration of the particle. So first you need to derivate it, right? So when you derivate the equation, you will get acceleration is equals to 3. The derivative of e is e, and then we need to take the derivative of its power, so it's 0.4, and the derivative of constant it will be 0. So we have derivated the equation, and now it says the acceleration of the particle initial, that means at t equals to 0. You have your acceleration 3, inside the bracket we have 0.4 t, 0.4, and the value of time is 0. So you will get 3, 0.4 and e to the power 0. Anything leads to the power is 1, so now you need to multiply 3 and 0.4, which will give you the value of 1.2. So you need to write down the solution in your copy, and you have a time of 90 seconds. So start. After that it says the displacement of the particle from O when t equals to 1. When it talks about displacement, that means you need to integrate now. So we have v is equals to 3 e to the power 0.4 t plus 3 2 are 6, and you need to integrate. So why don't you give it a try that how to integrate the exponential function? That will be a good revision for you if you can do it correctly. So try the question by yourself. First you need to integrate the function, find the value of c, and then find the final value of displacement at t equals to 1, and you have a time of 3 minutes. So start. Alright, so when you apply the integration on this equation, it will be 3 integral of e to the power 0.14 plus integral of 6. Alright, now what is the integral of exponential? The integral of exponential is exponential, but when you have the derivative part present next to it, right? So currently the derivative of the power is 0.4, which we don't have, so we need to multiply and divide by the constant here. So the division 0.4 will be taken as it is outside the integral sign, and now it's e to the power 0.14 times 0.4 dt plus integral of 6 dt. Now the derivative part is present next to it, right? So now the function is ready to integrate. So it will be 3 divided by 0.4, and it equals to 7.5. So it's 7.5. The integral of exponential is exponential, that means 0.14, plus the integral of 6, it's 60, and you have plus c. So when this is your displacement, when t is 0, displacement is 0, that means the value of c you will get, it's 0 as well. Now you have the expression for displacement 7.5 e to the power 0.14 plus 60. Now you need to find out the value of the displacement when t equals to 1. So we need to place the value of t 1 in this equation. So that will be s is equals to 7.5 e to the power 0.4 plus 6. So e to the power 0.4 times 7.5 plus 6, you will get s is equals to. Alright, now there is one mistake, and it happened when we find out the value of c. And what is this mistake here? Basically, when you place the value of time equals to 0, so let's check what happens to the equation. So when t equals to 0, s equals to 0, right? I mean to place the values here. 0 equals to 7.5 e to the power 0 plus 6 and 0 and plus 6. So this portion here, it won't be a 0 because e to the power 1, e to the power 0 is 1, right? So you got the value of c, it's minus 7.5. Now the expression for displacement is 7.5 e to the power 0.14 plus 60 minus 7.5. Now you need to place the value of time 1 here, so that will be s is equals to 7.5 e to the power 0.4 plus 6 minus 7.5. 0.4 e to the power 0.4 times 7.5 equals to 11.18, or you can say 11.2, plus 6 minus 7.5. So the final answer you get is 9.68 meters. That is your final answer. Alright, and further it says, will the particle return to O? So the answer is for part B, no. It won't return to O, because you can see that after 1 second the particle is 9.68 meters away from the origin, right? And if you observe your s value, right, distance value, so if you increase the value of time, it won't be lesser than 9.68, right? At t equals to 2, 3, 4, 5, 6, 7, the value of s can never be equals to 0. So that is why the answer is no. It won't return to the point O after t equals to 1 second. Alright, so I think that is quite enough for today class. And as a homework, what you need to do, you need to do the good revision of all the concepts which we have discussed so far. In the next class, we are going to start exercise 22.21.2. Alright, 22.2, sorry. That will be the same kinematics but more advanced level question.